to start simplifying this, we'll do the factor trees. For the square root of 4, what would be a quicker way to do it rather than doing a factor tree? Yeah, we could write that 4 as 2 squared. So I'm going to do that when I get to that one. Instead of doing 2 times 2, I'm going to do 2 squared because I know that one's a perfect square. Once I have those factor trees done, what's the next thing I'm going to do? We're going to rewrite this, and inside of each of those square roots, we're going to replace the radicand with the prime factorization. So in our first square root, we have the square root of 3 times 3 times 5. Then we have, for the square root of 44, it's going to be 2 times 2 times 11. And then we said for the square root of 4, since that's a perfect square, we can just write it as 2 squared. You could do 2 times 2 and circle the 2's, and that would come on the outside also. So either way would work for that. And then we've got a minus square root of 99, which would be 3 times 3 times 11. And then plus the square root of 80, which will be, there's a bunch of them there. It looks like 4 2's. So now that we've rewritten it, we have the prime factorizations and the radicands. One thing I want to point out is we didn't have any coefficients here to start with, but if we had any coefficients, we would want to make sure we bring those down when we rewrite it. Don't forget those, if there are any. Now what are we looking for? We're looking for pairs. So inside of the first square root, we have a pair of 3's. Second one, we have a pair of 2's. Next one, we don't have any pairs, but we have a square, right? So the square is going to do what? It's going to cancel that square root. Next one, we have a pair of 3's. And then the last one, we have 2 pairs, a pair of 2's and another pair of 2's. All right, so time for another rewrite. When I rewrite it this time, what's going to go out in front of that first square root? Okay, so we have 3 on the outside and 5 on the inside. All right, how about the next one? What goes on the outside?
2.
All right, and don't forget that's a minus, so it's minus 2 square root of 11. Okay, next one, we didn't have any circled, but we have a square canceling the square root, so what does that leave us? Just the 2 all by itself. Okay, then we have minus, what goes on the outside for the next one? 3 square root of 11. And then the last one, what do we have on the outside? 2 times 2 is 4, and square root of 5. Okay, now what? What are we looking for now? We're looking for like terms, right? So, do we have any like terms here?
Yes.
Yeah, we got a couple of them. So we've got the square root of 5's. Those are going to be like terms. And the square root of 11's are going to be like terms. And what about this 2 here? That's not a like term with anything, right? Now, just because it's not a like term doesn't mean we don't need it in our answer. We need that to be part of our answer still. All right, so there's three different terms that we're going to have in our answer. We're going to have some with the square root of 5's, we're going to have some with the square root of 11's, and then we're also going to have this 2. Which one of those should go first? The 2. Remember, when we have one without a square root on it, that's going to go first. So that 2 comes down. All right, then we have the square root of 5's and the square root of 11's. Which one of those should go first?
5.
The 5's, because they're, yeah, the radicand is the smallest. So we have 3 square root of 5, that's positive, plus 4 square root of 5. So 3 plus 4 is 7. So we get plus 7 square root of 5. All right, and then we have the square root of 11's left. That's a negative 2 and a negative 3. So if I have 2 negatives and I add on 3 negatives, I get 5 negatives. Negative 5 square root 11. Is there any way I can simplify this answer? No, there's no coefficients I can get rid of. Remember, when there's a 1 in front, we could get rid of that. What if there was a 0 in front? So if we get a 0 in front, like 0 square root of 5, that would just be 0, because 0 times the square root of 5 is 0. So if you ever get a 0 in front, that would just be a 0. We'll put a box around our answer here and we are done.